Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating article challenging the common assumption that Rails apps are inherently iodine monoxide bound. It's a really insightful piece.
I'm eager to hear this. The idea that database performance overshadows Ruby's role in Rails applications is something I've always questioned. Let's unpack this myth.
Absolutely. The article starts by highlighting the common belief that database bottlenecks define Rails app performance, making Ruby's speed less critical. But it argues that this conflates scale with performance. Scaling is about handling more users linearly, while performance is about speed and efficiency. They're distinct concepts.
So while scaling a Rails app often hits database limits first, that doesn't mean the app spends most of its time waiting for database I/O, right?
Exactly. The article emphasizes that typical Rails performance issues, like missing indexes or N+1 queries, are bugs, not inherent properties. Fixing these improves performance dramatically. Once you address these, the time spent waiting on I/O might be surprisingly small.
That's a crucial point. It's not about inherent limitations, but about good coding practices. The article mentions YJIT improvements as evidence, doesn't it?
Yes, the significant latency reductions reported by Discourse, Lobsters, Basecamp, Hey, and Shopify's storefront renderer using YJIT strongly suggest that these apps aren't primarily I/O bound. If they were, YJIT's impact would be far less pronounced.
Interesting. So the author argues that many perceive CPU starvation as I/O wait. How does that work?
The way I/O durations are typically measured, simply timing the database query, conflates query time with scheduling delays. A 20 milliseconds query time might include milliseconds spent waiting for the global VM lock, GVL, in Ruby, garbage collection, or OS scheduling. This misleads developers into thinking their app is more I/O bound than it actually is.
That's a really insightful point. It's a self-fulfilling prophecy. Assuming I/O-bound behavior leads to using more concurrency, which then confirms the assumption through logs. This is especially true on shared hosting, where CPU resources are shared.
Precisely. The article stresses that CPU-bound and I/O-bound workloads don't mix well. Microservices help by creating more homogeneous workloads, making it easier to optimize. But the GVL in Ruby exacerbates the problem in monoliths.
So, what's the practical takeaway for Rails developers? How does this impact deployment choices?
The article suggests choosing the right execution model based on the I/O/CPU ratio. Truly I/O-bound apps benefit from asynchronous models. I/O-heavy apps might use threaded servers, while apps with a balanced ratio might prefer process-based solutions. Rails' recent Puma configuration change reflects this understanding.
I see. And the broader implication for the Ruby community is to not dismiss Ruby's performance potential. There's room for improvement in both Rails and its gems, right?
Absolutely. The author emphasizes that developer happiness shouldn't come at the cost of performance. Well-designed APIs can be both user-friendly and performant, but this requires careful consideration from the outset. It's a great call to action for the community.
This was a really enlightening discussion. Thanks for breaking down this complex topic so clearly.
My pleasure. And thank you to our listeners for tuning in to Tech Bytes and News. We hope you found this discussion as insightful as we did. Have a great day, and we'll catch you next time.
Bye-bye.